detectors. So these detectors are used to process the output optical pulse received from the optical fiber to convert the optical fiber, that is to convert the optical pulses to electrical pulses or electrical signals. These detectors are used. So there are two types of detectors which are most commonly used in optical fiber communication, that is pin diode and avalanche photodiode. So let us see how pin diode is used as a detector. So pin diode is a PN junction diode which operates under reverse bias condition. It consists of three regions: a positive region, an intrinsic region or a neutral region, and the negative region. So when the light energy falls on the negative neutral region, electron hole pair is created. This electron hole pair is accelerated by an external electric field, giving rise to electrical energy. So now the photon energy or the light energy is directly converted into electrical energy. So this pin diode consists of three regions: P, intrinsic region or the neutral region, and N region. So it is written as PIN: positive, intrinsic and negative region. So this neutral region, that is the pin diode, is made up of a heavily doped material of gallium arsenide, where P material is also heavily doped and N material is also heavily doped, and the neutral region or the intrinsic region is slightly doped. In this case it may be doped with any type of material, either a P type material or an N type material. For our case, this neutral region or the intrinsic region is doped by an N type of material, So when this neutral region is made wider for more number of light energy to get absorbed, that is, this neutral region is made wider for more number of light energy to get absorbed. So now under reverse bias condition, when a light photon is incident on this intrinsic region, an electron hole pair is created. So this neutral region consists of less mobile charges. So due to less availability of less mobile charges, this area, the depletion area, is more. So now when a light photon is incident on this neutral region, an electron hole pair is created. So these electron hole pair created is accelerated, or these mobile charges are accelerated by an external electric field, directly producing electrical energy. This is how the light photons are directly converted into electrical energy. So this avalanche photodiodes also works under reverse bias condition, and this consists of 4 layers, where N1 is a heavily doped N-type material, and P2 and P4 are P-type materials, where P4 is heavily doped and P2 is slightly doped. This intrinsic region is also doped by an P-type of material. So now when the forward bias is applied, at a certain voltage, this depletion layer gets widened, or this depletion layer gets increased. Now a photon of energy, or when the light energy falls on this intrinsic region, a large amount of light energy is absorbed and an electron hole pair is created. So when the reverse bias voltage is increased, this electron hole pair is drifted through P2 and N1, and they collide with the free electrons in this region and create more number of conductional electrons. So these electron hole, when we increase the biasing voltage, reverse bias voltage, these electron hole pair created is drifted through from intrinsic region to P2 and N1, and they collide with the free electrons or the valency electrons, creating more number of conductional electrons. So these conductional electrons, avalanche photodiodes. Let us see how avalanche photodiodes are used to convert the optical energy into electrical energy. This APD also works under reverse bias condition. This consists of 4 layers. N1, P2, this is the I region, intrinsic region, and P4, creating large number of free electrons by avalanche effect. Thus, a single photon is capable of producing large number of free electrons by avalanche effect, creating the output current to be increased enormously. The output current has been increased. So thus, a single photon is capable of increasing the output current. So this avalanche photodiodes are called as sensitive diodes. So this is how an avalanche photodiode is used to detect the optical pulses from the optical fiber. Fiber optical sensors. Fiber optical sensors. An optical sensor is a transducer which converts any form of the signal into an optical signal in a measurable form. Here the optical fibers are used as waveguides. So now let us see how optical fiber sensor works. So it consists of an optical source where all the optical pulses, where the optical source is fed to a modulation zone. So here the modulation is done by any one of the property of the optical signal. There may be a modulation in the optical intensity, or in the modulation in phase, or modulation in polarization, or modulation in wavelength. With any one of these modulated signal is directly fed to an optical detector for detection. The fiber optical sensors are classified into 2 different types. One is intrinsic sensor, or otherwise it is called as active sensors, and the second one is extensive sensors or passive sensors. So intrinsic sensors are the sensors in which an optical fiber itself acts as a sensor. In case of an extrinsic sensor, the optical fiber is used as a waveguide.